All right, let's begin. So to quickly cover this week, we're going to start off with the class of the game class, as well as the user-defined functions and all of the asset managers. So here's our header file for the kitchen class. It has our start game, setting screen size, returning width and height, setting the window color and returning it, setting the window name and returning it. Then we have all of our private functions here, as well as some variables to use for the window as well. So inside the CPP file, we have the start game. This is called in the CPP and the main.cpp to begin the game. It will set an active flag to be true and then start running the game. When the game finishes running, we terminate it. This flag helps prevent the user from trying to run the game multiple times while it's already running. Beyond that, we have the set screen size. So we have it get passing a window with width and height, and we will use the engine call for width and height. After that, we return the width and height using either the get width or get height functions from the engine. For the get game time, we return the game time in seconds from the engine. For the window color, we return our defined window color variable. When we set the window color, we will pass in the given RGBAs, convert it into a vector, and then pass it into the set clear color. For the window name, same thing as with the window color. We set the name when the user gives it. We use the set window name from the engine. And if they ever want to get it, we just return the window name that we defined. For the initialize, we use the initialize game function. This is where the user defines all the window criteria. So if I just quickly run this to showcase the getters, because I did not use these two getters anywhere else in my code, we can see we got the 0.8, 0.4, 0.5, and 0.1. And then for the name, we have final presentation as defined up there. So just to run it, and we have no leaks. Beyond that, for the load content, this is where all the asset managers are loaded in, and where we set some of the defaults for the screen log. After that, it loads in the load resources, where the user calls in all of the different asset managers and wanting to load in each of the different colors, or each of the different associated assets. So we got the shaders, textures, models, images, and sprite fonts. This is also where they set the start scene as well. And once they finish loading all the resources, we start keeping track of time, and then we also initialize the current scene. For update, we have processing of time through the time attorney, and we also have the scene update through the scene manager. For the draw, we render all of our screen logs, then we do all of our visualizations, and then we do all of our scene draws. For unloading content, this is where the user-defined end game function comes in. After the user ends the game, we will unload all of our asset managers and unload all of our other managers in the game. When the terminate is called, we set active to false because the game is no longer active, and we delete the pointer instance, which once again, this is called here. For the actual text managers for the assets, so we have the texture manager here. It just has the preload and unload here fronted into the kitchen. Also, real quick, for the kitchen itself, it has the friending of the class for the time singleton and freezing time. These two classes are where these are the only two classes that can access the game time directly through the engine. Any other class will have to use the time singleton, which I will mention again once I cover that topic. But back to the textures. So we have the map keys. For textures, you can either pass in a file path, or if you just want a color, you can do the RGBA value. And here's some of the private stuff. We are using a map here. This is for the rapid find and also the log and insert. So if I go to the actual depiction of everything, for the default origin test texture, I decided to have a default texture because I was having a lot of issues with the origin, so I made something to make it more convenient. I feel like it'd be a useful tool for the user, so I kept it in, and that is the only thing that we preload. For if the user that wants to load something, they can pass in the map key they want to put it into, and then the file path. We check to see if the key is already being used. If it is, crash hard, crash fast. Otherwise, we try and open the file. If the file fails, crash hard, crash fast. And then finally, if all of that goes through, then we will insert into the map at the key. Alternatively, once the user can do the RGBA value, which if for some reason that fails, we will crash hard, crash fast. If it passes, then we just insert it into the texture map. And then also we check to make sure that they're not trying to reuse the same key. For getting the textures, once again, we have to check to see if that texture exists. If it exists at the key, we return it. Otherwise, we crash hard, crash fast. And then the unload, we iterate through our entire map and delete each of our textures that we created. For the shader, the attorney is identical to the textures. And for the header file, this one only has one type of option of inserting a file path, and also the getter is the same. We have a default for the sprite shader and a default 3D shader. And we are using a map once again for the constant find and the log and insert. So for the preload, like I said, I have two different ones, one for the sprite renderer and one for a default 3D texture. All of these names are using the engine name followed by what they are. When the user tries to insert something in, again, we check to see if the key is already being used. If not, we have two different files to test for the shader, so we test each of them. If either of them fail, we crash. If neither of them fail, then we create the new shader object. Getter is the same thing as the texture, just make sure the file exists, the shader exists already, and then return it if it does. Unloading, we iterate through the map and delete each of them. Models next. So over here, preload and unload, default things for the assets. For the loading, this is the most complicated one because there's three different ways to load a model. Same getter format, the default sprite key, using a map again for the same reasons. In the singleton itself, we have the key right here. We can preload it in. It's using the unit square XY as a ease of access for the kitchen sprite, which I'll cover in a future video. For the loading, we have the file path, same standard. Check if the map, check if the key is used. Check if the file can open. For loading with the pre-made model type, same thing, except instead of checking the file path, we check to see if they pass in an acceptable model type, and we check the key as well. For checking the plane size, we check if the key is used already. If it's not used, then we try to create the model with the given dimensions, and we crash if it somehow fails. Checking for the map, the model map. Once again, just make sure the key exists before trying to return it. And then we iterate through the map when it's time to unload it and delete everything. For the image singleton, we have a default test image. Like I said, for the sake of origin testing for sprites, I felt like it was useful to keep it in. We can load in with just a texture, or we can load in with a texture and a defined rectangle space. And then here's the privates, once again using a map. Here, the attorney, we have the preload and unload. Default origin test image, once again using the kitchen name and then the name of the location. This is using the get width and height of the texture. For getting the key, check to see if it's in the map already. If not, if it is, return it, otherwise crash. For loading with just a texture, if the user does not define a rectangle, then what we do is we will just get the texture's width and height and set that to be the rectangle. And the default X and Y is just 0, 0. I don't know why I didn't just put 0, 0 there, but that's what it is. For loading in with a rectangle, we just pass in the rectangle instead. And for both of them, we try to make it. We crash if for some reason it fails. And then we also make sure that the key that they're using is not already defined. Unloading, we go through the map and we delete every single image inside of it. The last asset manager is the sprite font, which once again has preload, unload. Here we have a default sprite font, a get and a load. This one does not require a texture to already be defined. It will create the texture itself because we're using a separate asset folder for that one. So for this one, we have the default font, which is just Arial, and then we insert it in using the font location. I will cover more about how the fonts are made in another video when we cover the sprites. But for the asset manager itself, once again, we just get it. If it exists, we return it. Otherwise, we crash. For loading, we check if it's a valid file path. And if it's not, we crash. Otherwise, we check here. And that's it for that. The last thing to test is to just showcase that trying to duplicate things will fail. So if I just duplicate this, if I make a false file path, rather if I duplicate, let me do it like this. Let me redefine it as a different type. Let me make a horrible file path, and we'll go through these one at a time. Because all of them are testing the same conditions. If any of these fail, then they'll all fail. So let me close this out. So we got the first fail from the shader singleton. This one failed because, if I scroll this up a bit, this one failed because we've already added the uniform color at that location. So if I go over here and let me delete this and run it again, we'll get our next crash at the frigate from the texture singleton because the frigate key is already being used. So let me comment that one out. And then finally for the axis, we'll get one more crash because for the model, the file path does not exist. Okay. And once again, if I were to just try and change that up for the texture singleton for the image, we'll get another crash. And last but not least, if I just go there, we'll get one more final crash. And that is every single asset manager and the game class.